Hello everyone. I wanted to make you a quick video about rationalizing a fraction. I know that many of you have had difficulty with this process, and so I just wanted to make a video where you can watch it multiple times if you need to, each time that you need to do this process. So here we go, rationalizing a fraction. Let's say that we had a fraction like the square root of 21 over the square root of 57. Now, I've chosen this because the only time that you're going to rationalize a fraction is when the denominator, the number on the bottom, has a square root in it, like this example. And here's what this looks like. We're going to multiply this times the number 1 so that it won't change the value of our fraction, because we're just multiplying by 1, but it is going to change kind of the structure of the way that it looks, because to have this fraction in simplified form in order to hand it in as our answer, we need to have a whole number in the denominator. We need to have a whole number, like 5, 15, 7 in that denominator. We can't have a square root down there. So the process is we're going to take that square root of 57 that we see in the denominator, and we're going to multiply by that on both the top and the bottom. Now, what's going to happen when we do that, when we multiply straight through here, we get 21 times 57 is 1,197. And so the top becomes the square root of 1,197. But the bottom comes out really, really nicely, because this is the square root of 57 times the square root of 57. That's the square root of 57 squared, which means this is only going to be 57. And so technically we've already rationalized our fraction, because when we look at the denominator now, we have a whole number like what we wanted. Now, what can often happen though when you do this process is it's still not a fully simplified fraction, because many times the square root that we have up here on the top can still be simplified further, and we call it breaking down a square root. So let's review the process of breaking down a square root as well. We take our number that's under the square root, 1,197, and we ask ourselves, well, can I multiply two numbers together and get 1,197? I want to try to break this down. And many people call this process finding the prime factors, or the list of prime factors of this number. Now, I know that it came from 21 times 57, so first I'll break this down into 21 times 57. And then I want to try to break those down even further, like what numbers multiply together to get 21. So I'll say 7 times 3 gets me 21. And then what numbers multiply together get 57? Well, that one could take a minute longer to try to realize what numbers are going to do that, but that is 3 times 19. And so what I notice is I have two of the same numbers in my list there. I have a 3 that happens twice, and 3 times 3 would get me a perfect square. So my goal here was to see if I can get in my list a perfect square. I want the biggest perfect square that I can in my list. So let's just rearrange these a little bit. We'll have the 9 up in the front, and then 7 times 19 is 133. So it turns out that I can break down 1,197 into 9 times 133, and 9 is a perfect square. So what I'll do with my square root up here at the top is I'll just change the way this looks by breaking it up into the square root of 9 times the square root of 133, and of course I still have that all over 57. Well, the square root of 9 is 3, so we can replace our square root of 9 with a 3. And now we have this, which is very close to being simplified, but 57 actually has a factor of 3. You could actually see that over here as well, that 57 is 3 times 19. So I notice that I can reduce my fraction as the last step by rewriting the 57 on the bottom as 3 times 19. I can cancel these factors of 3, and I arrive at my fully simplified answer, square root of 133 over 19. Now I hope that that helps in the full process of an example where you're rationalizing the denominator. The first part of this, where we multiply by the denominator square root on the top and bottom, that's the part where we're actually rationalizing our fraction. And then after that, I call this breaking down a square root. Breaking down. And we also have some simplifying happening down here as well. Let me know if you'd like another example of this, or you can watch this multiple times and try to go through the process with your example, so that doing the same process for you, you should be able to rationalize any fraction that has a square root on the bottom, and then you should be able to simplify that down to your final answer in its most simplified form.